Okay, so let's just go over our equations again. Equations of motion. So we've got x double dot equals 0, x dot because they're using alpha for this one. X is vt cos alpha. Y double dot is minus gravity. Y dot is minus gt plus this one's alpha, isn't it? So v sine alpha. So remember our velocity, initial velocity is v, and the angle they're using is alpha. So this is going to be v sine alpha, and this is going to be v cos alpha. So just make sure that's what you're using. Minus gt squared on 2 plus vt sine alpha. So we're saying our our beginning here is going to be our 0, 0. So x equals 0 and y equals 0 initially. All right. So here we're looking at the, what are we looking at? Prove the horizontal range. Oh, it was right at the beginning, that's why. So the horizontal range of the projectile. So it's going like this, and we want this range here. So basically we want this x value here. We have to find the time when it gets there as well. So of course, the time when it gets there, the time will be where y equals 0. So we're going to make y equals 0 and find the time first. So here's my y equation. So if I make y equals 0, I'm going to get gt squared on 2 is vt sine theta. So let's put the 2 on that side and the g on that side as well, and divide through by t on this side. So we get t equals 2v, and it's alpha. There we go. So we are getting this expression that they've asked us for. No, we're not, right? Because we haven't put it in. So that's the time where it occurs. We're going to put it in. We want our x value at that time. So we're putting it in our x value here to see, hopefully. So if I times that by v, I've got 2 v squared. I should just do it properly, but anyway. So I'm timesing the 2, the v, this, it's still got a t in it, and then we've got a sine alpha cos alpha here as well. Oh, we shouldn't have a t. Whoops. There we go. All right. So if I just put v squared on g at the front, you can see this 2 sine alpha, cos alpha, is the same as sine 2 alpha. It's the double angle identity. Which gives us that maximum, yes, now it's correct. So there's our, that's our range there, horizontal range. All right, so just finding t when y equals 0 and subbing that into x and using the identity that sine 2 alpha is 2 sine alpha cos alpha. All right, so that's our range. Okay, so if that's our range, I don't think we need that anymore. All that. All right, so we're told that this sprinkler, the initial direction of the spray varies continuously between 15 degrees and then 45 degrees. So those two. So just go back to what we found. We found the range was, so this is the horizontal range. It was v squared sine 2 alphas on g. So if we just put that in, clearly, well, not so clearly, but let's have a look at what the r's would be if we put in these two different angles. So if I'm putting in, let's say r1 here, 15 degrees, I'm going to get v squared sine 2 lots of 15, so 30 on g, and we know sine 30 is a half, so that's going to be v squared on 2g. If I look at, let's say R2 for the 45 degrees, I've got v squared sine 2 lots of 45 is 90 on g, and we know sine 90 is 1, so we just get v squared on g. So you can see that R1 is half of R2 because of that 2 there, right? So it's R1 is half of, so the range when we do 15 degrees falls halfway compared to the range when we're on an angle of 45 degrees. So you think about it, R is between V squared on 2G and V squared on G. All right, so that's why, explain why from a fixed point sprinkler will wet between, so an annulus with the inner radius of V squared on 2G and an outer radius of V squared on G. All right, so we know that, so let's deduce that. All right, so we've got a garden and we've got to place the sprinkler so that it wets the whole garden. So if you think about it, let's put, this means I have to draw, which is always an issue. So here we have, I'll do two pictures. So say we have an inner, there's our inner, the radius. So let's call that our R1. That's our radius there. And then where would we place this garden? So we want wherever that is to start, let's say, there we go, to be tangential to our garden so that, you know, it starts watering it there. And then, so our R2 will be up here. Yeah, so R1 and R2. So if you think about it, this is our 6x3 garden, and remember that R2 is I'm saying R2 is the bigger radius, so it's double our smaller radius. So if I draw I'll do a different color, see if this helps. So if I go like this and look at this rectangle here, so you can see this would be R2. All right, because that's the radius, and that R2, remember, is just two lots of R1. Oh, I don't know why I wrote that, which is two lots of R1s. This is half the rectangle's length, so that's going to be 3. And I guess we're interested in looking at, yeah, what would this be? So, oh yeah, so we know this length 2 would be R1 plus that 3. So that whole distance is R1 plus 3 in that triangle. So you've got this triangle here. So this is R1 plus 3. This is 3. And this is two lots of R1s because, well, it's really R2. Okay, so that gives us a condition. So if I use Pythagoras on that, you can see that we get R plus 3 squared plus 3 squared has to equal R2R1 squared. Let's see what that is. So these are all R1s, by the way. So R1 squared, 6R1, now we've got a 9 and then another 9, so 18. And that's going to be a 4R1 squared. So if we put all the R1 squareds together, that's going to be a 3R1 squared, that's a minus 6R1 and a minus 18. If I divide through by 3 just to make it easier, we've got R1 squared minus 2R1 minus 6. So let's solve using quadratic formula. I'm just going to write it over here. So R1 is negative b plus minus square root of b squared minus 4ac. So minus minus is a plus. 4 6 is a 24 on 2a, so on 2. So you can see we're going to get a 1 plus or minus a square root of 24, 5, 6, 7, 8, 28. 28 is 4 7s. So if we square root that, we get 2 root 7, and then we divide by this 2 on the bottom. So we've just got root 7 there. Now, we want a radius that's positive, so since R1 has to be greater than 0, then we're looking at R1 being 1 plus root 7. So think about it, it has to be at least, so R1, remember, was our V squared on 2G. So we're saying that V squared on 2G has to be at least 1 plus root 7 in order for this to work, the garden to be watered. So we can always make it bigger than that, that's fine, but we need at least that.